Welcome, Extension 2 students. Let's look at this very difficult Argand diagram question from complex numbers. So, we're saying z minus 1 over z modulus is smaller than 2. So it's a difficult question. We definitely can't just do it by geometric interpretation, and we have to do some tough algebra. So my first recommendation, method 1, I will do Euler's formula. Why? Because there is this term, which is 1 over z. It will be very easy to use exponential for it. And let's go for it. So that's z equal to r e to the power of I theta, and then we can plug it in. And this is using the property of exponentials. And then we expand it using Euler's formula, and then we just separate the real and imaginary term, and then we use the modulus formula, and then we use brute force to expand it. See how these tricks you can use their property to make it 1 very easily. Using this step to this step, it shows how powerful Euler's formula is and how much it made our life easier. And now, after we reach this step, which is a critical step, we basically can't make the mistake of just square rooting both sides, because if you do that, you get, hypothetically, if you do that, which I did very stupidly, of course you also need to discuss the positive and negative case. But if you just intuitively get this, right, well, you can't do it because we haven't learned polar equations, and that's just not working. So if it's not working, we just move it to the other side, and then we use the difference of square formula to get this result. And then having this, we basically know that one of it is negative. Now, it's a very common result. It's a very common method as well. If you want to show that multiple things, one of them is negative, you just multiply them together and it's 0. So if you want to show, this is how you show is 1 is 0, and if you want to show positive or negative, you can also do that. This means one of them is negative. Now we have this, we can make this 0, but one thing we need to do is we actually need to convert it back to polar form. We need to have a Cartesian equation. We can't have a polar equation because it's out of syllabus. We haven't learned it. So how do we do that? We use these sets. X is r cos theta, y is r sin theta, and r squared is x squared plus y squared. So now we can break r up. We can break it up from here to here, and we can also see that this is actually x. And then we can basically go like this, and then we just simplify to this case, which everyone knows how to do. You draw a circle, and then you find the area. Now one of them is negative, so these two cases, and their corresponding diagram are this. So between this, it's end. So you find the intersection, which is this part. So it's this part, this part, and this part. Now we need to, and then this is all, so it's find the, both of them can be true, so it's these two. Now, just a little trick, you can actually do this in decimals. So first step, you need to use the complex mode in settings. And second step, you need to have this is definition. After that, you can use modulus. You can also use this arg, so you can do everything, and it's beautifully rendered, and you can see the result, but don't over rely on it. You should think of it by yourself first. Second one, brute force. So it's the usual method, right? You just plug it in. So you plug it in, it's all this complex algebra, but if you are Extension 2 student, you're expected to be able to deal with this amount of algebra. Now the real hard part is when you reach here, how do you do this? If, say, you decide to expand this, then you're kind of cooked because there's no way you can do it. If you expand this fully, which I tried before, let's see what you will get. Okay, I can't find it, but you will literally get this. You will get this, and you have no idea how to plot this. You always need to factorize, but it's very difficult, and you can't do it. So do not expand this. You can simplify these terms. You simplify these terms. You move them here, and you make this the subject. So you can actually do this manipulation. This is hard. I acknowledge it. It's hard. That's why it's inferior to the Euler's formula method. Like, you need to make sure you don't expand this. Then you move it here. You create this term to create a square minus a square, and you get this result. And all the rest is literally the same as method 1. So using this video, you learned 2 methods, the brute force method, and you just need to make sure do not expand this. You also did the Euler formula method, which you learned that you must convert it back using this set of formulas, because you can't have polar equations. You can't have polar equations, so you convert them back to Cartesian ones using these. I think this one is a good method. It's the one that I enjoy. I give it a star. So use this one. And thanks for one of my followers for providing this very valuable question. I really appreciate it, and this channel is being greater and greater with people sending these valuable questions, and I'm very grateful. And see you next video.